the last thing we're going to look at here are our two functions inverses of each other. And all that's required here is to find the inverse of one of them, because if it gives us the other one, we know they're both inverses of each other, and if it doesn't, then they are not. So for instance here, if we want to know if these two functions are inverses of each other, we can pick either one of them and find the inverse of it. So I'm going to take f of x, and I'm going to start by switching x and y. So f of x is my y, and it will become x. And x squared will become y squared. And I'm going to solve for y and see if it gives me g of x. So to solve for y, I add 5 to both sides. X plus 5 equals y squared. And the last step here is to take the square root on both sides. And we have to be a little careful here. When we take the square root, we have to take the square root of the entire side. If we had taken the square root of just x, it would equal g of x, but it also wouldn't be correct. So y equals the square root of x plus 5, which is the same thing as that was f inverse of x. So f inverse of x, the inverse of x is the square root of x plus 5. And that is not the same as g of x, even though they look somewhat similar. Another thing we could do is remember that inverses have inputs and outputs switched. So for instance, I can take a point, and what I would look at here is, for instance, I could take a point on g of x and say when x is 1, I know I will be able to do the square root of that easily. When x is 1, the square root of 1 is 1, and 1 plus 5 is 6. So g of 1 equals 6. Has the point 1, 6, which means that, so here's for g, that means the inverse of this should have the point 6, 1. So to see if they're inverses, I can plug and see if 6 gives me 1, and 6 squared, so f of 6 is equal to 6 squared is 36, and 36 minus 5 is 31. So that does not equal 1, and so these are not inverses of each other. Now, testing one point and having it work isn't good enough to see if they're inverses, but seeing that a point doesn't work is good enough to see that they're not inverses. Let's try this on another example. Here we have m of x equals 2x plus 6, p of x equals 1/2 x minus 3. I can pick either one of these and try to find the inverse of it. Here I'm going to pick p of x, and I'm going to see if the inverse of it is m of x. So I'm going to switch x and y. X equals 1/2 y minus 3, and I'm going to solve for y. I'm going to add 3 to both sides. So I get x plus 3 equals 1/2 y. To get rid of 1/2 times y, I need to divide by 1/2, and dividing by 1/2 is the same as multiplying. So dividing by 1/2 is the same as multiplying by the reciprocal of 1/2. And 2 divided by 1 is just 2. So multiplying by 2 is how I get rid of dividing by 1/2. That should make sense, right? Half of 8 is 4. To get rid of that, we multiply by 2. 2 times 4 gives us back to 8. We have to remember to multiply the whole side. When we multiply, divide, square root, square, most operations except for adding and subtracting needed to be done to the whole side. So here we get 2x plus 6 equals y. And that is, so this is p inverse of x is equal to 2x plus 6. And so p inverse of x, the inverse function, is m of x. And that tells us right away that the inverse of m of x will be p of x as well. It goes both directions, because remember, if you switch x and y one way and you switch it back, that would give you back to the original x and y. So it doesn't matter, if x, y switched gets you to yx, then if you switch this, it will get you back to the other one. So they are inverses of each other. Again, I could try like that input-output trick. So m of 1, if I put in 1 here, I get 8. 2 times 1 is 2. 2 plus 6 is 8. And so I need to see in p of x. So here I've got the point 1, 8 in m of x. So in p, I should have the point 8 comma 1. And let's see if we do. P of 8, when we put in 8 for x, half of 8 is 4. 4 minus 3 is 1. And so that does work. Now, checking just one point isn't good enough to say that they're inverses, but it should at least reassure us we didn't make any mistakes. It's a good way of checking. There's one last thing that we would get to in a slightly later part of the year that we don't have quite all of the math that we need to, especially in some of the quadratics and cubics and stuff, which is that if you do a function of a function, if you do f of f inverse of x, it will always get you back to x. Because this is saying, also if you do f inverse of f of x, it gets you back to x. This is saying, okay, you put in a function, you get whatever output there is, and then you do the inverse function on that output, that will always get you back to the original input. And what plugging a function into another function looks like is taking that function and putting it in where x is. So here's what p of m of x looks like. P of m of x means we plug in what m of x is equal to into p of x. And so that's going to say p of x says 1/2 times x minus 3. And p of m of x means we plug in 2x plus 6 in for x. So it looks like this. 1/2 times, instead of 1/2 of x minus 3, we put in 1/2 of m of x. Oh, sorry, I have a red. Plus 3, minus 3. So you can see that we plugged in m of x in for x. And when we simplify this, half of 2x is x, half of 6 is 3, and x plus 3 minus 3 is equal to x. It always gives us back the initial input. And when we get slightly more advanced in our math, this is what we'll end up using. But for now, solving the inverse for one and seeing if it gives us the other is good enough.